Hello everyone, Assalamu alaikum. Welcome to the new syllabus, finding the point of inflection or inflection point. So let's see the definition first. The inflection point is a point in which the concavity of the function changes. It means that the function changes from concave down to concave up or vice versa. In other words, the point in which the rate of change of slope from increasing to decreasing or from decreasing to increasing manner. So that is what it means by inflection point. We just need to find the point that is our goal. Let's see what is concave up and concave down. So concave up is a curve opens in an upward direction. So like this, it opens in an upward direction to make a shape like a cup. While concave down is a curve bending down, that it resembles a cap. So we need to know the concavity, whether it's up or down, in finding the inflection point. So let's see this concrete example without wasting time. Let's read this example 1. Find the inflection point of fx. So this is our function. Let me highlight it first for you. This is our focus of the function fx, and then we need to sketch the graph. So the first step is we need to find the derivative and then equal it to 0. Okay. If you forgot about the first step in exam, you will have a huge problem. So I would recommend, if you memorize this, you put an effort to it, please memorize that the first step, the second derivative, find it yourself, and then make sure you equal it to 0 to find the value of x. Let me show you how. So first thing first, of course, we need the first derivative. Okay, we cannot just simply straightforward getting the second one, right? We need to go to the first derivative first. So the first derivative is 6x squared minus 24x plus 18. And therefore we can go to the second derivative, which is 12x minus 24, and make it equal to 0. I repeat, equal to 0 is important. If you forgot, you will mess up. So here we go. The next step is just factorize it, and then there you go. This is my value of x. So I just got my value of x, and this is going to lead me to the inflection point. So inflection point, I will put it as IP, so that you know from now onwards, when I say IP means inflection point. So inflection point means we need a coordinate, isn't it? Coordinate means, a point means a coordinate, so we lack of the y coordinate now. But before we go to the y coordinate, I think it's best for us to go to the second step first, in which the table is to determine the concavity of the graph. Okay, again, I repeat, when you find the IP, you cannot get rid of this concavity. You must have it for the second step. So here is the example of the table that we have prepared for you guys. You can just follow the table here. The first one is, of course, the interval. You just put in the value of x that you have got just now, which is 2. And so x means here just the test value between the interval. Here goes, I choose 0. You can choose 1 or -1, up to you. And here goes, I'll choose 3. So this is f prime, the second derivative. So you must refer to your second derivative, yeah? This is your second derivative. Sub in the value, okay, sub in the value of 0, your test value, into this second derivative, you will get a negative sign. While this one, you sub in 3 into the second derivative, you will get a positive sign. Yeah, like usual that you have done before. There's so many times that you have done this. So after you have got the sign, you just make a conclusion. If you see a negative sign, it means it is concave down, while if you see a positive sign, it means a concave up. As easy as that. And then here we go. The next step is finding the point of inflection, which is you are almost there. You need the coordinate, isn't it? You need the point where you already have the value of 2, and so you need the coordinate of y, and it's very easy. You just sub in the value of 2 that you have got previously into the function of fx, isn't it? Like this. You sub it in and you will get 9. Therefore, the coordinate is 2, 9. The point of inflection or inflection point or IP, it is 2, 9. This is a very important value, a point that you must got. And then the last step is sketching part. So sketching part is a bit tricky for everyone actually. So what I can suggest you is that whenever you must look at this function first. I would say sketching is a bit tough, isn't it? But I would suggest you look at this positive sign first. Oh no, this this is cubic, right? So cubic graph is sort of like this shape, okay, or this shape. So at least you already know that the basic shape already in chapter 5, and you must also know that this is a positive. So positive cubic is this kind of shape lah. Okay, as long as you already know the shape, the pattern, you will have no problem. And most of it, the cubic for chapter 10 is having a minimum and maximum point, you see. So we cannot get rid of finding the max point and the minimum point. So here we go. Let me go up a bit. So here is the important step in order to find the mean and the max point. So you have learned this previously. To find the mean and the maximum point, the first derivative must be equal to 0. You have known this, right? So when let's just do this, okay? We need to know the mean and the maximum point if there is a mean and max. So this is just try and error, okay? And whether you will find the mean or max in this cubic function. So here goes. I factorize, I just simply would like to divide everything here with 6 so that I got x squared minus 4x plus 3, and then make it equal to 0 in order to find the value of x. So here we go. This is my value of x. My value of x is 1 and 3. So I can just move forward in finding my value of y as well. We want to find a point, isn't it? So use your calculator, sub in the number 1 and 3 into the original function fx. And so I got here 13 and here is 5. Therefore, my point is 1, 13 and 3, 5. So by using the second derivative test, okay, I need to know whether this point is max, or this point is max. Which one is mean, which one is max. So in other words, I need to use the second derivative. So after using the second derivative test, I know that this is a max point and this is a mean point. Okay, in this video, I do not need to teach you how to use the second derivative test. You can go to my previous video and look on how do I get this point, mean and max. Okay, this is a very quick video. This is a very just quick recall. And so after you have found your mean and max, and here goes, let me put in, where is my max just now? This is my maximum point. Yeah, let me just label it first so that I am focused on how to draw it. So this is my mean and maximum point. So I would like to just draw a short shape here. This is my max and this is my minimum point. So basically you can look at that we are almost there. You know, if you have a mean and maximum point, it's easier for you to sketch. So I forgot to tell you that this is not IF, this is IP. So sorry, this is IP. This is your 2, 9, isn't it? So I think it's very best to just put in your inflection point, IP, first. So this is IP, okay, inflection point. So inflection point, again, if you read the definition, inflection point is a point in which the concavity changes. So the concavity changes from concave down. This is concave down, isn't it? This is concave down, changes from concave down to concave up. So it is between that point, you know. So oh, so sorry about that. Just hang on a bit. So you just, after you know that, after you know that this is your inflection point, and you already know that your maximum point and minimum point is between that, you just join them together, isn't it? Just join the line. Maybe I should use green color. You just join the line here. Oops, maybe I just yeah. So you just join the line and make it a bit longer. This is going a bit further up, and this will be going a further down, and therefore this is your function fx. And how do I know it's going across the number 5 here? Because when x is 0, the y-intercept is 5, therefore it go through the number 5. So basically this is how you draw you sketch your graph. Okay, it's not that hard. Just as long as you know the inflection point, just find it first, find your IP first, and then know your max and the mean, and you can double check it from your table. Yeah, this is concave down, yeah, this is concave up between the point 2, 9, and you are good to go. This is your graph. You have no problem at all. And I would like you to try the second concrete example by yourself, and please try it yourself, and let's see whether you got this one. If you got it by yourself, it means you are ready for chapter 10 in exam. Good luck then. Thank you.